Hello everyone, this video is for lesson 12, which is reviewing for test 1 in quarter 1. We're going to start with number 1, and number 1 is asking what is the difference between drawing and constructing something? For example, what is the difference between drawing a perpendicular line and constructing a perpendicular line? Okay, so we spent a lot of time discussing the difference. And if we are asking you to draw something, a drawing is a freehand. It's like doodling. Right? So it's not perfect, right? You're drawing something. It's not perfect. But if we're going to ask you to construct something over here, if we're asking you to construct something, that has to be precise. And the way it's precise is by using your tools. So if we're asking you to construct a perpendicular line, you're going to use your compass and your straight edge, right? That's the difference between constructing and drawing. So literally, if we ask you to draw, we don't want to see a perfect diagram. It should be precise. It should look like a doodle. Okay, number 2. A student has done the following construction down over here. What was the student attempting to construct? And is there more than one thing that the student could be constructing, and explain? So there is more than one thing that the student could be constructing right now. First, if I take this dotted green line and I go from here to here, the student could be constructing a perpendicular bisector. If I take this blue and I go from here to here and here to here, a bit thick, let me change this, something like that, the student could be constructing an equilateral triangle. So put this here. Either a perpendicular bisector, and that's by connecting both intersection points, or an equilateral triangle by connecting an intersection point to endpoint A and so one construction could really kind of lend itself to either one of those. All right, number 3, it says sketch a segment and the perpendicular bisector of that segment. Okay, let's do that first. Let's sketch a segment. I'm going to put this here. It's a segment, so I am going to put some endpoints on my segment. Perfect. And now it says the perpendicular bisector of that segment. Okay, so my perpendicular bisector should be perpendicular and through approximately the middle. Take a look how I can, something maybe like this. Excellent. Now remember we talked about the perpendicular bisector and it should have arrows on the ends. It looks something like this. Okay, so that's my sketch. Now it says to label the diagram and identify 3 equal parts and 3 congruent parts. Okay, so let's first label the diagram. First thing I'm going to label is this point right there. Then maybe green. There's a point right there. And I'm going to label that point M, because that's going to be my midpoint. Okay, so let's move that. I'm going to label this over here R. I'm going to label the other endpoint P. And then I'm actually going to put a point here on my bisector and point down here. And I'm going to just label that, I don't know, H. And I'm going to label down here. Yes. So now I can now start identifying some things based off of my labeling. Now, in addition to labeling all these points, I have to think about what a perpendicular bisector does. So I can actually mark up my diagram, right? We talked about if this is the perpendicular bisector, it takes RP and it cuts it into two equal parts. So here are my two equal parts. I can mark that and that. Secondly, if it's perpendicular, I have 4 right angles. So I could add in that little right angle box right here. So now let's just talk about what it is that's going on, and then we'll identify the equal parts. So the first thing that we know is that RP is going to be perpendicular to HS. So to show that two things are perpendicular, you could use that upside down T. We have RP is perpendicular to HS. RP is a segment, so I'm going to put a little bar over it. HS is a line, so I am going to put arrows over this. Okay. We also know, we just said that there are going to be 4 right angles. And we said that there's a midpoint, and that's because HS bisects RP. So we can take this here, here, and then that tells us that M is the midpoint of RP. Now that I have all these conclusions, I'm going to come up with 3 equal and congruent parts. So the first thing I know is let's deal with the fact that we have a midpoint. So that means that RM and PM are going to be equal. Remember, since they're equal, they're also congruent. Congruence is different because you have that little squiggly on top. So let me see if I could just put like the little squiggle. And that means that RM and PM are segments. So I need to put the bar over it. Whenever you're dealing with congruence, you have to have the proper notation. Okay, now that's it along RP. But what we talked about in class is that if I actually compare the length from H to P and H to R, it's equal the same way from R to S and P to S would be equal because all the points on this perpendicular bisector are equidistant from the endpoints of my segment itself. So I'm going to connect H to P and H to R, and I'm now going to write another statement. I'm going to write that HR is equal to HP, and then I also know that HR is congruent to HP. And then with my congruence, I actually need to show congruence by putting this little symbol on top. And HR and HP are both segments, so they need the bar on top. Okay, now the final piece of what's equal are these right angles right here. So I'm going to use 3 letters to name the angles that are equal, and I'm just going to pick 2 to compare. So I'm going to say angle PMH is equal or congruent to angle RMH. So if I'm using equals, I have to say their measures are equal. So the measure of angle PMH is equal to the measure of angle RMH. Now I can take this exact statement and turn it into a congruent statement by taking away the little m for measure. And then just adding on top of the equal sign, that little squiggly. Now this says PMH, angle PMH is congruent to angle RMH. Okay, so there are your three equal and congruent parts. And here are the statements that kind of lead you to those parts right here. Okay, number 4, give 3 possible correct names for the given angle. Okay, so 3 ways to name this angle. First, you can just focus on the number that's in the vertex, which would be angle 1. So you could have angle 1. Okay, then you could look at just the vertex. You're allowed to use just the vertex if the vertex names only one angle. So the other name that we could have here could be angle C. So angle C, angle 1. Erase this. Then you could use 3 letters to name this angle. So I can use letter A, C, B, or B, C, A. So angle A, C, B, or angle B, C, A. That is how you can name that angle 3 different ways. Okay, number 5, what does it mean to bisect something? So when we bisect something, all we're doing is we're cutting it into 2 equal parts. So you could get 2 equal angles, 2 equal segments. You're just getting 2 equal parts. Okay. Next page, let's take a look. And it says, use the diagram to complete the relationship. Okay, so based on what you see here, these little tick marks are telling us that AM and BM are equal. So here, AM and BM are equal. Okay, now we know if they're equal, they are also congruent. I can take these, copy it down here, and the only difference is now when we're talking about congruence, it's with the little bar on top. They're segments, so segment AM is congruent to segment BM. Remember, order matters, right? So I'm going from endpoint to midpoint, endpoint to midpoint. Okay, here, what do we have that's equal or congruent? So you take a look, and specifically, if these are both marked with X, it means that they're equal. So this angle, and I can kind of trace over it, I have this angle here, which would be BAD, and this angle here, I can call this angle, CAD. So then we could have angle CAD. Okay, so let's write that in here. If we're dealing with equals, we have to put the M in front. So we have the measure of angle CAD is equal to the measure of angle CAD. Remember, order matters, right? I went from the outside to the vertex, the one that's kind of on the inside, and then I did the same thing, outside vertex to the letter D that was on the inside. Now for congruence, I take the same 2 statements and I just take away the M. Congruence, you're not talking about the measure, just kind of comparing them. So angle BAD is congruent to angle CAD. Okay, number 7, choose which construction matches the diagram. Okay, so how would this first be finished? It looks like they opened up from A to C, swung an arc, moved it to B, swung an arc, and then to C and swung an arc. So the last step here would be to actually complete the diagram. I would go from A through D, and that means I just constructed an angle bisector. So let's change this, and I'm going to circle angle bisector. That's C. There we have it. Okay, 8. Draw, so I'm going to do this freehand, a diagram based on the following description. Okay, a circle circumscribes a hexagon. So that means that the circle for A, the circle is around the hexagon. Okay, let me first see if I can do this. I'm going to sketch here on the smartboard and see how this goes. I'm using a mouse, so it might get a little messy, but that's okay. All right, so I'm going to draw a circle to the best of my ability. Put a hexagon in there. All right, so it's here, 1, 2, 3. Nope, that's not a hexagon. I think because my circle isn't too nice. So let me see how I can make my circle a bit nicer. Ah, here we go. Okay, so 1, 2, 3, 4, 5, 6. All right, let's see. There it is. Okay. Good enough, right? 1, 2, 3, 4, 5, 6. Okay. Now B says a hexagon inscribed in a circle. That means that a hexagon is inside. Remember, inscribed means it has to be touching the circle. Wait, that's the same thing. The hexagon is already inside the circle, touching at all the vertices. So this actually is the same diagram. So we're done. All right, 9, let's construct the angle bisector of the given angle. Okay, so let's see what we have here. Now, first and foremost, what's really important is that they actually gave us 2 points, H and T, on this, on the angle. And just because they give you H and T, let me show you what I mean. It doesn't mean that you actually have to open up your compass to H or T. So I'm just going to open up my compass to this length here. So when you do the angle bisector, first part is you swing an arc, right? And then you focus on the 2 intersection points here and here. Take your compass, move it to that intersection point, as so. And now I have to swing 2 more arcs. At this point, you can choose to open up your compass a little bit further. You don't have to. That's completely up to you. I like to just stretch it out. Okay. And now I put this on the intersection point. I swing an arc like that. Okay. Take the same compass width, go to the other intersection point, swing an arc. And to finish the angle bisector, take my straight edge and I go from the vertex through the intersection as possible. Now, again, the arc does not need to go through H or T. There are just 2 points on that angle, so don't worry about if it doesn't go through it. That's not a big deal. All right, let's see what we have next. Number 10. We have to find the midpoint of segment YS and label it E. Okay, so in order to find the midpoint, we actually have to do the perpendicular bisector construction. That's what number 10 is all about. Let's take our compass, perpendicular bisector. So we take our compass, we set it up so that it's at one endpoint, go more than halfway. I'm going to choose to go 3/4 of the way, and I'm going to swing an arc under, and then you need another arc above. Take the compass width, leave it the same, go to the other endpoint, arc that intersects down here and over here. Finally, perpendicular bisector, take my straight edge, go through, make sure you have arrows on the end. That's the most important part. Like so. Go here, arrows. Have to label the midpoint. We should put a little point here and label it M. All right, we are, oh wait, nope, label it E, my bad. Doop. So put a little point here, E. Yes, perfect. Okay, number 11, construct a line parallel to line K that also passes through A using copy and angle method. Okay, so we're using copy and angle, and we're getting lines that are parallel, has to go through point A. Okay, so first step, if we're going to be constructing a line parallel using the copy and angle methods, we actually have to get an angle. So to get that angle, we're going to take our straight edge, and we're going to form an angle that goes through point A and crosses line K over here. Put a little arrow at the end over here. Okay. Now we're going to copy this angle down here at point A. So I'm going to take my compass. I'm going to copy an angle. So in order to copy an angle, you start the vertex. And you're going to swing an arc so that it goes through both sides of your angle. Bring that same exact measure now up to point A. Swing the same size arc approximately. Okay. Now, down here, you have 2 points of intersection. You have a point of intersection here and here. You only have one point of intersection up here. So I need to now take my compass, go back to my original, and measure from intersection point to intersection point. Bring that up to the point of intersection up here. Swing an arc. And now take your straight edge and go through A and the intersection of those arcs. Perfect. And now this is a line that's parallel. So we should have an arrow on both ends. To show that they're parallel, you can actually put the two arrows on the lines as well. Remember, video, you can stop, rewind, pause, so on and so forth. So that's how you copy an angle and get parallel lines. Now, for 12, it's different. We want lines that are parallel. We're going to be using perpendicular lines. Okay, so in order to do that now, I have to do my line perpendicular to K that goes through A. So this is basically your smiley face and then your perpendicular bisector. So we do a smiley face and then the perpendicular bisector. Okay, so let's do our smiley face first. So I'm going to go needle on A, pencil past the line, swing a smiley face. Okay, now I have 2 points of intersection here and here. Show them. So point intersection here and here. So it's the perpendicular bisector of that segment now. Now because my point is above the line, I actually only need to have my arcs under the line. So here, and let's go here. Now take my straight edge, and I go through the arc, and you want to make sure you actually go through point A. So now these lines are perpendicular. Okay, so a little right angle here. I also need now a line perpendicular to A. So I'm going to do the smiley face and perpendicular bisector construction again, except now, when I put it on A, I'm going to actually shorten this up a little bit. Swing my smiley face, and actually like a full half circle almost. Okay, and now I'm going to use this point and this point, and now do the perpendicular bisector. And this has to be the full perpendicular bisector. So I have to go more than halfway, and I need arcs above and below the line since the point is on the line. So an arc above, to the left, and to the right. Okay. Oops. And I'm going to go to the other point of intersection. Down here. Intersect. Intersect. Another line. Perfect. Put an arrow at the end. Excellent. And now they're perpendicular. So if two lines are perpendicular to the same line, these lines must be parallel. So there we have that. Okay. Let's move on to number 13. We're almost there. So 13 says construct an equilateral triangle inscribed in a circle. So that's when we start with a point. So we're going to start with the point. We need now a circle. Because if it's inscribed inside of a circle, you need your center. And now you have yourself a circle. So you swing yourself a circle. For this construction, you use the same compass width, and you pick a point on the circle. We call this stepping around the circle. So I put my point, take my compass width. Now I quote unquote step around the circle. So I swing an arc, and now I'm going to take my compass and move it to my new point of intersection. Swing another arc, keep on going around the circle. I should get 5 arcs, and I have myself 1 point. Okay, and to get yourself an equilateral triangle, we're just going to connect now every other point. So I'm going to take this point, I'm going to skip, connect this point, skip, and then connect to this point. So I take my straight edge now, and I go point, point, and there you have an equilateral triangle inscribed in a circle. Now, 14 is very similar to 13. So in order to construct a regular hexagon inscribed inside of a circle, I'm going to do the same first three steps. So the first step was to start with the center, and then it was to swing a circle, and then it was to step around the circle. So you put a point, and now I'm going to step around the circle. So 1, 2, 3, 4, and the fifth arc. And now to get a hexagon, there are 6 sides, so we need all 6 vertices. So 1, 2, 3, 4, 5, 6. Remember, inscribed means that the vertices are touching the circle, so you have to make sure that you're actually getting the intersection of the arc and the circle. That's where the vertices of that hexagon should be. And you're done. There's your hexagon inscribed inside of the circle. Okay, so now finally we have to do a square inscribed inside of the circle. So for the square inscribed inside of a circle, we're going to start the same way. We need a circle, sorry. So I take my compass, put a center point, I swing myself a circle. Okay, so now we're going to draw the diameter, and then we're going to do the perpendicular bisector construction of that diameter. So let's get started. Let's draw on the diameter. And once you've drawn the diameter, you now have 2 of the 4 vertices of your square. The vertices are the endpoints of the diameter. So here and here, okay? So now we need to do the perpendicular bisector. I'm going to take my compass. Perpendicular bisector construction uses one endpoint, and you have to open up more than halfway, something like that. Swing an arc above. Remember, when you do this, if your arcs are inside the circle or on the circle, that's okay. The way I opened it, they're outside the circle, but that's okay if yours are inside the circle. Other endpoint, you're keeping the compass measure the same. Okay. Have my arcs, perpendicular bisector. Now draw it in, so make sure that it goes through the arc. Should have arrows on both ends, so let me get an arrow on the other end. Okay, and now this gives me my 2 other vertices. They would be here and here, and to get the square, we connect all 4, as so. And now we have a square inscribed inside of that circle. Okay, so that finishes up the review sheet for the test. Remember, you will have a chance to ask questions both in class as well as during the Google Meet. If you have any other questions, please be sure to reach out to us through email or commenting in our Google Classroom.